Hey everyone, so today I'm going to tell you about dark matter and dark energy. So give you the basics about all of them. So I'm going to first tell you the distribution they have in the universe, then I'm going to tell you what they are, how we know they exist, where they are, what are they possibly made of, and I'm going to give you a summary, okay? So, what is their distribution of the universe or the energy distribution we have in the universe? Well, 69% is dark energy. 26% is dark matter and only 5% is normal matter. So that means that 95% is actually invisible to us and unknown to us because we don't quite know what dark energy and dark matter are, okay? What we know is that dark matter produces an attractive force. It's kind of a gravity, while dark energy produces a repulsive force, kind of works as an anti-gravity. And we know they do not interact with light, so we can't see either of them. So it kind of looks like we have something trying to pull things together, something trying to push them apart, and we kind of have a cosmic tug of war. So the gravity of dark matter tries to pull the universe together, the dark energy tries to push it apart. In the beginning, dark matter dominated the early universe, but dark energy began to dominate it about 5 billion years ago, okay? And as the universe gets larger, the dark energy domination is going to increase because dark matter, if it's working as gravity, needs the bodies to be massive and also close together. And as you know, the force for gravity is like 1 over r squared. So as you increase the distance, then the force of gravity becomes weaker. So that is why dark matter is at the moment losing this fight or this cosmic tug of war. Now, how do we know they exist? Dark matter exists because visible matter doesn't have enough gravitational ensemble to hold galaxies together. So we needed something else, matter that we cannot see, but it had to be there to explain how galaxies formed. And dark energy exists because our universe is expanding, which indicates some unknown force is fighting the gravity's pull, causing galaxies to move apart from one another. This expansion is at the moment accelerating, and all we know is something that we don't know and we never saw before is kind of acting as opposite to the gravity, which is what we're supposed to be seeing, okay? So that's why we say it's dark energy. Dark because we never saw it, it's invisible to us. Now, what are they made of? Now, people don't quite know, okay, but there are two possibilities, which are machos or WIMPs. So, machos are massive astrophysical compact halo objects, so they are quite dense, okay, and WIMPs are also dense, they are weakly interactive massive particles. So, this is the assumptions that astrophysical astronomers have at the moment. I was going to say astrophysicists and astronomers at the same time. So, we believe they are made of machos or WIMPs, or maybe we have different machos and WIMPs making different types of dark matter and dark energy. Maybe they are not exactly the same, just like we have electrons, protons, and neutrons, which are made of different combinations of quarks and antiquarks. Maybe dark matter and dark energy don't need to have all exactly the same composition, okay? Now, if they are invisible, how do we know where they are? Because we kind of say there's dark matter in here. So how do we know where they are? Well, the outer parts of our most galaxies spin much faster than we expected. If the only thing providing galaxy to hold them together was visible matter, they would fly apart. So there must be some extra matter out there that we cannot detect yet. So if we cannot see it and it's invisible for us and is matter, we call it dark matter, okay? So here you have an animation that I got it somewhere in the internet. So on the left is what we observe, the galaxy spinning around itself much faster, and on the right, what we expected with the amount of matter we actually have. And as you can see, spins much slower. So for the galaxies to spin as fast as they seem to be spinning, or as fast as we observe and calculated them to be spinning, we had to be having more matter, and this would be this dark matter, okay? Now, in summary, nobody really knows what dark matter and dark energy are. They are dark, they don't interact with light, so we can't see them. Here are the names: dark matter, matter because it's gravity, or helps gravity or acts like gravity, and energy because it's kind of anti-gravity. But we do need dark matter and dark energy to make our model match what we actually see in the universe. So we cannot ignore them. We cannot just say that they do not exist, because once we do the calculations, imagining that we have this amount of dark matter and this amount of dark energy, things fit, okay? Dark matter is something that is pulling things out or together, so like gravity. Dark energy is much more mysterious, but it almost does the opposite. So it seems to be pushing the universe further apart rather than pulling it together. And at the moment, it seems that dark energy is winning the fight between dark matter and dark energy, meaning that the universe is expanding, things are further and further apart more than before, and the expansion is accelerating. Okay, so I hope it made sense. I hope you enjoyed this video explaining you a little bit in simple terms what we believe dark matter and dark energy are, why, although we don't quite know what they're made of and they are quite mysterious, we believe that they must exist. Okay, although there is a recent theory that says that maybe they don't exist at all. But anyway, once we know more about that and how reliable it is, we can talk about it more. But anyway, so you got to know that. And as always, up to my next video, I hope you keep happy and healthy, especially with this pandemic going on. Okay, so stay safe, stay at home as much as you can, only leave with if necessary. Okay, so up to my next video, be happy and healthy. Bye.